Right, good morning class. Right, at this point you got your test back. The test will be done towards the end of the first lesson. Of this lesson. It's just mark the homework, do something new. And the balance of the time you can wrap a mind or a head around what has hit you in the last test. Okay. As I said, those questions came out of a cycle test that was written at the school not too long ago. Okay. People, your homework was exercise. What? 2.3. Sorry? 2.3. I'm actually on the wrong page, no? We are in exponents. 2.3. Right, in 2.3 you have to do second column. People, any problems there? Okay, I'm just going to close the door. You know what's wrong with these people? They are not in a maths class, that's right. Maths, you can't make so much noise. Yeah, we just sleep, eat and sleep, no? That's all we do. And okay, let's hope so. Right, people, exercise 2.3, let's just get the textbook open. Right, which page are we on? 44. So we are around about there. (2.3) page 44. People, the second column, any issues there with number 1? You can say no, and then the exam come and you get what you get. No. You got very good marks for once. Who said you got very good marks? Nayan, is that good for you?
No, so.
Oh, you gave me a shock. Okay. People, number 2, any issues there? Number 3? Number 4? You don't have to do. Okay, for homework I want you guys to do 2.3, the remainder of the sums. Whichever sums it was not completed, you complete for me, okay? Is that okay? So now we're looking at the rational exponents. Rational exponents. And that's on page 45. Rational exponents on page 45.
Sir?
Yes?
We're going to do trig next time.
Trig. I think you're going to do trig this term still. What did you hear of trigs? Huh? Well, why do you ask specifically about trigs? What? That's why I'm asking you. What have you heard about? Trigonometry, yes? It's fun, yes. That it is very. It is fun. Trig, yes, geography. And it's in physics. Yeah. Trigs are used across the different subjects. Okay. People, rational exponents up till now, our exponents have been integers. Not so, either positive or negative whole numbers. We now introduce new definitions to allow us to work with rational exponents. So the definitions for rational exponents, it's listed on page 44. Okay, so I'm just going to pull it up here. Page 44. So the definition for n is an element of natural numbers. N has to be greater than 1. M is an element of integers. And A is greater than 0. Greater than 1 is all values that is bigger than 1. So it's 2, 3, 4, 5 and so on. Where M is an element of integers, there's negative and positive whole numbers. And A is greater than 0 then. So first definition here, we are told that a to the 1 over n is equal to the nth root of a. So whatever the denominator is there, can you see there the denominator here? That will always be the root there. In number 2, you got a to the negative 1 over n, can be the nth root of a to the negative 1. And number 3 is a to the m over n, can be written as the nth root. Again, n is the denominator of a to the m. With these definitions, all the laws of exponents also hold for rational exponents, which means to say, when you're multiplying and bases are the same, you add the powers. When you divide, you subtract. If a power is raised to the higher exponent, multiply the exponents. Exactly as we had before, still applies here. Okay, so now we're looking at the example 1 on page, what page is it? 44, no? Example 1 on page 44. We are given 2 to the exponent of half. 2 to the exponent of half. So they ask you to simplify. Okay. So what did we say? The denominator will always be the root. So that will simply be the square root of. You see there is a 2, so there is a 2 and a 1. You guys understand? Yeah, that's really simple. Number 2. But now, of course, we don't write the 2 and the 1 there. No? It's simply written again. This is example 2, on the same page. It says simplify. You've got a to the negative a third. A to the negative a third. What's happening here? So that's going to be, this is called exponential form, and this is your radical form, or your third form. Okay, you guys okay with that? So this will be the cube root of a to the negative 1. Not so. Now a to the negative 1 can be written as what? 1 over 8, yes. There's a cube root of 1 over 8. What's a cube root of 1? 1. What's the cube root of 8? Alright, you guys understand? Any confusion? No. Let's look at example 4, 3 and 4. Okay, there's example 3. Example 4. Okay, looking at example 3. In example 3, you ask to simplify. So, 4. First write it in third form. 4 to the exponent 3 over 2 is what? The square root, because it's 2 as is the denominator there. It's the square root of 4 cubed. What is 4 cubed? 64. It's 4 times 4 times 4. 64. The square root of 64 is? Okay. You guys understand? Alright, so I'm going to give you a chance to do the next one. Quickly, yeah?
So it's like 2 over 8.
Yeah? 4 to the exponent 2 over 3. Okay, so this would be what? The cube root of 4 squared. And what is 4 squared? 16. Is 16 a perfect cube? No. So you leave it. You understand? What are perfect cubes? 1 cube is 1, so 1 is a perfect cube. 8 is a perfect cube. 27 is a perfect cube. 64 is a perfect cube. So if this was the cube root of 64, it would have been 4, and so on. Okay? 125, 1,000, and so on. No? You guys understand? Right. Let's look at using laws of exponents. So it's on page 44. So you next up reading using laws of exponents. This is the first example of this type. We assume that all denominators are non-zero and the variables are positive. Why must the denominators be non-zero? Otherwise the sum will be undefined. And the variables are positive. Okay. I think these two you guys can do on your own. So I'll give you a minute on each. Each one. Right, let's go with the first two. Example 1 on page 44, it says simplify. Using laws of exponents now. Simplify. So what did you do first? Add like terms. Multiply the inside the bracket. So that's going to be 8 cubed times a to the exponent 4. It's 8 to the exponent? Raised to the exponent negative 2. Now what? Multiply the exponents. So what do we get? Sorry? A to the negative 14. Negative exponent, we must always write with positive exponents. So that will simply be 1 over a to the 14. Any confusion there? You all got that answer, no? Let's look at the next one. Example 2 on the same page. The question says simplify. You got 2 to the 2x times 3 to the 2x. What do you notice about this sum? exponents are the same. So I can multiply the bases. Just taking one step back, if I had 2 to the 2 times 7 raised to the x, and I write that in simplified terms, what would that be? It will be 14x, yes? What else would it be? If I get rid of the brackets, it would be 2 to the x times 7 to the x. Can you see the bases of the exponents are the same? So what I'm trying to show you here is that you see the bases are the same. Sorry, the exponents are the same. So I can write the bases together. So it's 2 times 3 raised to the 2x. Not so. And what's 2 times 3? 6. So it's 6 to the 2x. Okay. Any confusion? No? So now we're looking at exercise example 3 on page 45. In example 3 on page 45, the question states, state whether the mathematical statement a squared b cubed is equal to ab to the 6. Is the statement true or false? False. Okay? So the answer to A is false. B. Motivate your answer by using a numerical example. So let's choose a value for A. Let A equal to 2 and B 5. Let's go 2 and 5. I could have chosen 2 or 3 or a 3 and a 2 or a 5 and a 7, whatever you want to choose. But don't choose a number 1. Okay, because 1 to the exponent 2 and 1 to the exponent 1 is the same answer. Whereas 2 to the exponent 2 is 4 and 2 to the exponent 1 is 2. So it's different. Can you see that? So, importantly here, we would say if the left-hand side of what? Of the equal sign. Okay? This is a proof or show that question. So you must show the left-hand side equal to the right-hand side of the statement to be true or false. So the left-hand side, if A is equal to 2, what would it read? 2 squared times B, which is 5. And 2 squared is 4. And 4 times 5 is 20. Let's look at the right-hand side. Sorry? 5 cubed. Why did I choose 5? It'll be a big number now. 125. And 4 times 125? It's not 600. It's going to be, sorry? 1,000. 500. You sure? Yeah, it's 500. Let's look at the right hand side. Sorry about that. It's going to be A. And what is A? 2 times B, which is 5 to the exponent 6. So it's 2 times 5 to the 6. It's 5 to the 3. So it's 125 times 125. It will be a big number. Work it out. 5 to the 6. That's why I'm thinking now. Why did I choose 5? 15,625. 15,625 times 2. Twice as big as that number. 31,250. So is it the same? Therefore, the left-hand side, in conclusion, that's therefore, it's not equal to the right-hand side, which supports our claim that it is false. Okay. Will you guys understand? It's fairly simple, no? And the last of the examples is number 4. You've dealt with something like this before last year. The sum is just a bit bigger, so I'll give you 2 minutes to sort that out first. I'll pause the video at this point. Alright. So let's go. What do we do first? 2 squared. 2 squared is what? 4. A to the exponent? 4. We multiply the exponents. B to the exponent? Times A cubed. B 12. All over 16. A 12. B. You guys got it? So what do we do now? Sort out our numbers. The 4 goes into 4 once, 4 goes into 16. 4 times. That's 1 over 4. So I multiply my variables on top. So A4 times A4 B6 multiplied by A cubed B12. What would that give us? A7 B18 over A12 B8. Where is there more A's on top or at the bottom? Bottom. So it's going to be A12 minus 7 is? Where is there more B's? Top. It will be B or 1 B10 is the same. So will you guys understand? Any confusion? Alright. So we said we're going to do the answers of the test that you wrote yesterday. You didn't score too well in as a class. So I need to spend some time on that. Okay? You are writing on these topics on Monday, Tuesday. Okay? So for homework is going to be exercise 2.4, the first column throughout the whole exercise. This is very, very important for Monday's lesson. Okay? This exercise, you must do it so that we can have a better lesson on Monday. Alright? So your homework is exercise 2.4, page 46 and 47. Okay. You try and put the homework immediately into the group. Okay, so 10 o'clock at night, nobody's asking what the homework is. Okay. Who asked yesterday? Alright. But anyway, listen. So I gave you the test. It's test 2. It's going to be part of this video. I'm going to record it anyway. Now, this topic that you were tested on in class was on algebra. Okay, I know that this video deals with exponents. So if you're watching this video at this point and you don't want to see what the topic on algebra was, you can just bypass it. Okay, you can just forward it towards the end and see if we're still busy with the test. Otherwise we should be answering part of exercise 2.4. Okay, the page is full, so I'm going to delete this page. Oops, no, don't. Here on the second page. Now this, don't forget the assignment for Monday, no? You got a lot of work. You should have started it already. Okay. Likewise with the exponents topic. You go to the back of the topic. You'll also find a check your skills exercise there. Try and answer those questions along, because that's going to be your next assignment again, and so on and so on. Okay. And that is how we keep up to date, or keep on revising our work. Okay. Because I'm sure you guys want to do well, no? Or don't you want to do well? Right, here we go. So class test 2. So what do we need to do here? We must multiply, get rid of the brackets. Okay, so we multiply these two first up. That's a conjugate pair. So I can multiply the first and the last. So it's negative 6a into a4 minus g squared. Now what do we do? We multiply negative 6a in. So negative 6a times a to the 4 is negative 6a, fine. Negative 6a times negative a g squared is positive 6a g squared. Okay. I don't know if you guys took this as only a class test, so you don't have to worry about it. But this gives you a clear indication of what you know if you are in an exam setting. Okay? So you must start taking the class test even serious as well. Okay. Any issues here? Your misunderstanding you want to share? You want to clear? Anybody? No? Right, 1.2. In question 1.2, how many terms are there? 2 terms. Not so. So, before we can add and subtract whatever we need to, simplify, multiply, get rid of the brackets. Okay. So in the first term, we are going to multiply those 2 brackets out, so it's negative 3a into. What's a times a? A squared. A times negative 2, negative 2a. 1 times a is a, which is negative a. 1 times negative 2 is negative 2. Not so? Minus 2a. So this almost reminds me of the difference with the sum of cubes. Let's check if it is the case. Is your first term squared? Yes. Is the last term squared? Yes. Is the sign opposite to this? Yes. What's a times 5? 5a. So that will result in the sum of cubes. Not so. If any one of those conditions were not met, then it wouldn't have been of that type. Since it is of that type, what can I do? I can multiply the first and the last. It's not always the case, no? You must check as I did. If you don't know how to check that, no problem. You multiply the whole story out all the time. Okay? So what's a times a squared? A cubed. 5 times 25? It's 125. So what do I do now? Now we multiply. Get rid of the brackets. Okay, so what's negative 3a times a squared? Negative 3a cubed. Negative 3a times a, negative a. It's positive 3a squared. Negative 3a times negative 2. It's positive 6a. Negative 2a times 3a cubed. Negative 2a 4. Negative 2a times positive 125 is negative 258. So what do we do now? We're going to add like terms. So let's write it in DCV powers of a as well, one time. So it's going to be negative 2a4. Is there like term to negative 3a cubed? No. Is there like term to 3a squared? No. Is there like term to 6a? Yes. Which is negative 250. So that will simply be negative 244a. positive 6 minus 250. It's negative 244. Okay. Any confusion here? Alright. The question is to factorize. Ask you to factorize. So, what's the square root of x squared? X. What's the square root of 16? 4. You see as a minus and a square. What is x times negative 4 times 2? Negative 8x. So yes, it's a perfect square. Your answer. Say you didn't see the perfect square trinomial again. No problem. What are we supposed to do? Product line. What are my factors for 1? 1 and 1 for 16. 1 and 16. 2 and 8, 4 and 4. Do we add or subtract? We add. That's going to give you 16 and 1 is going to give you 17. That's 8 and 2. 8 plus 2 is 10. We're looking for a negative 8. 4 and 4 is going to give 4 plus 4 is 8. How do I know I'm adding? Because that is positive. Okay. So it's going to be a 1 and a 4. A 1 and a 4. Okay. That's a 1 and a 4. 1 and a 4. So there's x squared. So there goes an x and a x. What about our signs? It'll be the same sign. Both plus or both minus. In this case, both is going to be minus. But to write this in the simplest form, it would simply be x minus 4 squared. Okay. Again, the question is to factorize. Okay. So what is common here? 2a minus b, but this is not 2a minus b. So what must I do? I must get it the same first. So what do? I swap this around. I swap that around and negative comes out. So it's b squared into 2a minus b minus y squared into 2a minus b. So what happens now? Now we have a common factor of 2a. It's 2a minus b. If I take this out, what am I left with? B squared minus y squared. So it's 2a minus b. So that's going to give you b plus y. B minus y. Any confusion there? Again, it's just going to say no. You must say what you don't understand. I would never know. 2.3? Again, the instruction is to factor. So first I must get rid of this bracket here. I'm going to write that x in front first. I know most of you can multiply the negative and the x in one time. There's no problem with it, okay? So we multiply that out, we get x squared minus ax minus bx plus ab. So what happens now? Factorization by grouping. So what's common here? X. I'm left with x minus a. What's common there? Negative b, because the first term is negative. The first term is negative. So it's x minus. Now what? Common factor of x minus a. And I'm left with x minus. Okay? Any confusion there? No? The last one, 2.4. Again, the instruction is to factorize. This is going to be the, what's the cube root of x to the exponent 9? X to the exponent 9 is x cubed. What's the cube root of 8y to the exponent 12? 2y 4. So that's going to be x cubed. So it's the difference of cubes, no? Minus 2y4. Whatever sign is here, you write there. Okay. So what we do is square the first term. If I square x cubed, if I square that, what do I get? x6. This is negative, so here must go positive. X cubed times 2y4 will be 2x cubed y4. And the last term squared, which is negative 2y to the exponent 4, will be positive 4y to the exponent. Okay. Yes. So again, how do I get x6? Because I say x cubed, and it must be squared. But the middle term is going to be the opposite operation, so there's minus, there goes plus. X cubed times 2y4. And the last term must be squared, that number will always be positive. So that's going to give you x6 plus x cubed times 2y4. I could have put a minus here and the negative there. It's going to be the same thing. Eh? It's going to be 2x cubed y4 plus 4y. You understand? And what did we say about this trinomial here? It will never factorize. Alright? So any issues here? No. So what I'm going to do is at this point I'm going to pause the video again and I'm going to give you a chance to answer some of the sums I gave you for homework. Okay? So let's start there. Exercise 2.4 on page 46. If you have a problem, you can come to me now as well. We try and sort out the issues you're having, okay? Problems with the maths, no? Not your lives. Alright, I'll pause the video at this point. Okay, so let's answer these questions quickly. Right, so the first answer is a squared times a cubed, a5. The next one, it's going to be 6a, 5. The next one, so when you're multiplying the bases are the same, you add the exponents. Not so. So it will be 5, negative 2 plus 4 is 2, which is 25. The next one, x over y times x over y times x over y. X over x times x times x is going to give you x over y times y times y, y cubed. The next one, a squared times a to the negative 2 times a to the 0. That will simply be a to the negative 2 plus 2 is 0, and 0 plus 0 is 0. Anything to the power of 0 is 1. The next one, x over 2 times x over 2 times x over 2 is x cubed over 8. M. M. Here we have 8 goes into 8 once, 8 going to 16 twice. A4 over A squared will give us A squared. The next one can be written as A squared over 2A to the exponent negative 4. Not so? So this can be written as, so is there more A's on top or at the bottom? On top. So it's going to be A.
My apologies for the interruption. The
2.
following 3 learners can you please report to Miss Van Heerden's classroom
2
immediately?
minus 4 will
Jaden
be
Pastor,
6 over.
Sisiko Kiswa, and Libongo Mantla. Jaden Pastor, Sisiko Kiswa, and Libongo Mantla to report to Miss Van Heerden's classroom immediately.
For those of you looking confused, remember when we divide and base are the same, what do you do with the exponent? Minus, subtract. Between 2 and negative 4, 2 is greater, so it must go to the top. So it will be 2 minus the number at the bottom, which is negative 4. Can you see that? So that's going to be A, 2 minus minus 4 becomes 2 plus 4. And what is 2 plus 4? 6. Now you guys understand? People enjoy the weekend. Good morning, class.